Okay, so you survived this week. Intense week, right? And really, I'm sure some of you are thinking, well, the last few weeks have been intense, and that's true. The last several weeks have all been building to this week. How do we how do we take a look at all this data that we've collected, and then summarize it into just a couple pieces of information that are be passed on to the public or communicated to the public in general on what our research actually found. And there's a couple central things that we looked at this week. So there's the concept of statistical significance, and this is what we're talking about: p-value, confidence interval. We can calculate this, but this is a mathematical, precise definition that may or may not be useful when it comes to any specific decision that we're looking at. And then there's this concept of practical significance. And the practical significance answers the question, does the results of this research, do the results really matter? So statistical significance is a mathematical question that can be answered purely mathematically, just as long as you have the data. And the practical significance is one that involves more thought, where you have to really think how it applies to your life, how big the effect size was. And that practical significance is the one that really matters. I hope that point got across this week. So the statistical significance usually centers around the p-value. And the typical rule is if p-value is less than the alpha level that you set, which is usually 0.05, then you reject the null and you accept the results of the study. And that's what's very common practice in statistics. But because that's kind of a brainless decision, right? You're just comparing a number with an alpha level. We need to think a little bit more about what's going on if we really want to take full advantage of what research offers. So even in this week's Excel task, you calculated a p-value, but you also looked at effect size and confidence intervals. Now, confidence intervals is kind of a cool thing because it tells you whether or not to reject your null. So if your null hypothesis value is not inside the confidence interval that you created, then you're saying it's unlikely that that null is true, and you reject the null. So you can use it kind of like a p-value to determine the statistical significance, but you can also use it to get a sense of what the range of likely values is, which tells you, are you right on the border or are you well within the range. And then we looked at an effect size also for that list. And an effect size, the problem with effect size is there's several different ways to measure it. There's Cohen's d, there's r squared, there's lots of different measures. And when it comes down to it, you can do one of two things. You can either, if you're reading an article, whatever measure of effect size they use, you can look that up, just Google it and find out how high of an effect size that is. Or you can kind of trust the author when they interpret, this is a D of 0.15, we're saying this is a small effect size. And sometimes, honestly, that may be the best thing to do because the effect sizes do differ from field to field. Nursing is very different than some of the psychology studies, and even inside nursing, even inside psychology, there's a lot of variance on whether or not a specific effect size is really large or medium or small. So because the journal articles are peer-reviewed, you can hope that there was some awareness and honesty of whether that effect size was small, medium, or large. But that's a very important question to look at. When you're reading a study, the classic example is you're maybe reading the news and you see this new food significantly reduces the risk of cancer or significantly improves your chance of living longer, something like that. yeah, well, you need to go in there and check, because probably that's going to be a statistical significance, and it may be a very, very tiny effect size, especially if they had a big sample. It's very possible to have a small, small effect size, but still get statistical, mathematical significance. And what you really care about in the big picture is practical significance. So looking at whether or not it's significant is statistically significant is important, but that practical significance, that's the crucial point that I'm trying to get across this week. That practical significance is the important thing. Statistical significance, the p-value, as I've said, has achieved almost a cult-like status among researchers and the general public, to be honest. There's that article I shared, the Leonidas, about why most published research findings are false. That goes into the details of why maybe you shouldn't put all your faith in a single p-value. Another one of the videos showed why we never want to put too much trust in a single incident of research, because there's always the type 1, type 2 error risk. But a body of research that all points you in the same direction, that does start to get fairly trustworthy, especially if the effect size, the practical significance is relatively sizable, then that does say something, and that's how research should be used. Dangers. So there were some optional things you could watch or read in your discussion section. One of those was on Merck and what went down with the Vioxx scandal, and how they tweaked the data because they were right on the border of that p-value, and they wanted to be right on the other side of it. So is there really a difference between a p-value of 0.049 and 0.051? No, not really. Not really. But because they have to draw the line somewhere, in terms of reporting statistical significance, you better believe there's a difference. 0.049 is significant, 0.051 is not significant. And that's not great. That's why p-value can be seen sometimes as a brainless decision. It's good to look at for a starting point, but you really need to look at that effect size. I think I've repeated that 5 or 6 times in this video right now, so hopefully that point has gotten across loud and clear this week. So yeah, there was a lot of crazy mathematics going on with calculating the p-value, the theoretical distributions, but the real thing I want you to know is when it comes to interpreting the results of a study, don't just look at the p-value, look at the effect size. Okay.